Hi guys, so I wanted to follow up on today's class work and make sure that you guys understand the topics well. For this reason, I decided to create this quick video to go over some of the homework questions. So starting with number 1 on the homework 1B. The question asks vertex and either the absolute max and minimum. So we're trying to find each element, intervals of increasing, decreasing, C, domain and range, D, all X and Y intercepts, E, intervals where the graph is positive and negative, and F, and lastly F is axis of symmetry. So let's start with the vertex. So remember, vertex is the highest or the lowest point on the graph. In this case, it is this point. And we label the vertex as an ordered pair. So we write vertex, and then in parentheses, the x and comma y values of the vertex. In this case, this point that I just highlighted here, or pointed, is 0, 20. Because it has no x value, or actually the x value should be 0 versus the y value is 20. Part B, for part B, we are, and by the way, we can add to that. We can add that the vertex is here is an absolute max, right? It's the highest point. Remember, absolute max, we talked about this in class, absolute versus relative max. Absolute is the really highest point on the graph. In this case, the vertex is the absolute max, is the highest point. B, intervals of increasing, decreasing. So where is the graph going upward? That's increasing. Where's the graph going downward? To go back and revisit this portion of the graph is where the graph is going upward. So it's increasing on this interval. And this portion of the graph, in green, is where the graph is going downward or decreasing. So when they ask us for intervals, they are technically asking us, or we are being asked for x values. These are intervals of x values for which the graph is increasing or decreasing. So they, in other words, they're saying, what are the x values that correspond to this portion of the graph, right? And technically, they mean, okay, the graph starts increasing from this point on the x-axis to this point on the x-axis. So technically, we are in this interval, which means, and remember that -3 is an open circle, so we are in the interval, we are increasing on the interval, which interval, starting with -3 open circle, comma, all the way up to 0. That's where the graph is increasing. And then decreasing is the green portion. So similarly, you are mapping onto the x-axis. You are mapping the y values, aka the graph, onto the x-axis. So you start here at 0 and you go all the way to 3. And again, you can put 0 closed 3 or 0 open 3. It doesn't matter. And what I mean by open and closed means open circle or parenthesis. So it's decreasing on 0, +3 or 3. Okay, so this is increasing versus decreasing. Part C, domain and range. Domain, all the acceptable x values. So the x values for this graph, they go from -3, from this point, there's an x value, all the way to 3. But again, notice that -3 and 3 are open circles. So we're going to have really parenthesis -3, 3, close parenthesis. Otherwise, if these were closed circles, it would be brackets, okay? Or if one of them was a closed circle, then it would be bracket by that point, or that coordinate, I should say. Then in range. So up and down, how far are we going up and down? The lowest point on this graph is this point here. Notice there is no graph below this point. There's no representation of the graph below this point. And the highest point on the graph is here, above which there's no graph. So your graph is going from 4, but you have to be careful about 4. 4 is also an open circle. That's why we put a parenthesis 4, comma, and then we go all the way up to 20. 20 is included on the graph, so it will have a bracket next to it because we do reach the value 20. So it's included. D, all x and y intercepts. Where does this graph, remember x-intercept is where the graph meets or crosses the x-axis. This graph doesn't even cross the x-axis. The x-axis is below this graph, so no x-intercepts. And the y-intercept, or let's see if we have, yeah, we do have one, which is right here, which happens to be the vertex. This is where the graph meets the y-axis, aka the y-intercept. That's the name of this point, right? The y-intercept. It happens to be the vertex. Not always it is the vertex, okay? But in this case, it happens, this point, the point in pink, happens to be the vertex, and at the same time, it's the y-intercept, because it's where the graph meets the y-axis. So what is the value of that? The y-intercept is actually 0.20. E, intervals where the graph is positive or negative. Now remember, the graph is positive above the x-axis. So this is f of x being positive above the x-axis. And it's negative below the x-axis. So we're being asked for which value of x is the graph above the x-axis. And basically, if you look at the graph, the entire graph is above the x-axis. So really, f of x is positive, meaning above the x-axis, for all the values in the domain, which is what? Which is -3 to 3. So if you go from -3 to 3, you'll only have a graph that is above the x-axis. And because we don't have a graph below the x-axis, so we don't have a negative value for y, then basically there's no interval for which the y value or f of x is negative. Then for part F, it says axis of symmetry. Now recall from class that the axis of symmetry is technically a virtual axis. So it's not really there, but it's an axis that splits the parabola into two symmetrical and equal parts. In this case, it's this virtual brown line. So I need an equation for it. Because this line is vertical, meaning that it cuts the x-axis. Therefore, the equation for this line is what? Is x equals to 0. We call that the axis of symmetry, or A.O.S. So just keep that in mind. If you see A.O.S, that means it's an axis of symmetry. Hopefully this was helpful for you guys. Hopefully you you can pause, rewind, go back, and just learn at your own pace. So this is one part that I wanted to go over. Another part that I wanted to also go over, and maybe let's go to the next page. Let me clear this. And we can go to the next page and maybe do something that is more algebraic. This was done in class. Let's maybe try, let's try number 3, and maybe we can try number 4 after that. So for number 3, the question is, what's the domain? Now, we agreed in class that if we see a graph like this, we're technically assuming that these ends are going indefinitely, right? So there are arrows there, basically. Meaning that this graph keeps on going and going and going. We just don't have enough room to graph it. So where is the domain? What is the domain, right? Let me not write domain again. Use the space efficiently here. So where is the domain? These x values, if you go to the, basically you keep going here on the graph, it's going to map throughout, or it's going to map against the entire x-axis. So all these values of the graph will have an x value. And if you keep going to the right, you will also map against the x-axis. We mentioned this in class, and we said that the domain for a quadratic is always -infinity to infinity. So keep that in mind. Now for the range, The range is the y values. So think about going from the lowest point all the way up to the highest point, if any. For the lowest point, we're going here. It's a little bit below -2. So I'm going to call it, this point here between -2 and -3 is exactly -2.5. And this is almost halfway, a little bit less than halfway. So I'm just going to say -2.2 approximately, comma. And then the graph goes all the way up. So it's going upward. This is a problem that opens upward. So really, the range is going to go all the way up to positive infinity or infinity. Interval of increasing. Where is the graph going upward? The graph starts going upward, if you think about it, kind of like from this point and to the right. From the vertex and to the right, you see that the graph is increasing. And you can see that the graph is decreasing on the other end. But let's do one at a time. So for increasing, which x values, right? So where does it start? Which x value does it start at? And you can see here that for this vertex, the x value for it is 1/2 or 0.5. So this graph is increasing from this x value 0.5, and as you go to the right, it continues to increase. So from this, you're saying from this point on, my graph from this x value and on to the right, my graph is increasing. So therefore, you say the interval of increasing is 0.5, comma, infinity, or 1/2, comma, infinity. And if you want to include 0.5, feel free to do that. You can put a bracket here, but normally we can stick with just parentheses, it's fine. So decreasing is the other side. Decreasing is the other side, which is technically this side. Because as you go to the right, you're going down. So all the way from -infinity, notice here, if we keep, again, mapping this graph, if you keep going and mapping it, it comes from -infinity all the way. So from -infinity all the way to this point, which is, again, here, 0.5. So the graph is decreasing. So interval of decreasing is from -infinity, comma, 0.5. I hope this is clear. And you can, again, go back and revisit, pause. Interval where the graph is positive. So again, positive. Positive means the graph is above the x-axis. So this is positive. And this is positive. And versus this part of the graph is what is negative. It's below the x-axis. So I want the values of x for which the graph is positive. What values of x is the graph positive for? So you can see that from this point and to the left, the graph is going to go upward above the x-axis, which is positive. And from this point and to the right, the graph is what going to be also positive. So how do we say that? From this point and to the left, from -1 and to the left. So we would say from -infinity, comma, -1, that's the first part. And then the second part, I'm starting here at 2 and to the right. So you would say union 2, comma, infinity. Remember, union, the U here for union means or. Or in other words, in more student-friendly terms, it's like saying together with. Okay, so this is where the interval is positive. The interval of x, or x values, for which the graph is negative, which is the pink portion, this goes from the rest of the stuff, which is here, from here to here. And that's from -1 to technically 2. So between -1 and 2. And notice these are technically the endpoints, right? The endpoints here. They usually are. So we're not introducing new values. Okay, next is average rate of change. And this is where some of you were struggling, but let's go back and revisit this portion. The average rate of change, we thought about it as, we talked about a slope when we said this is changing on a quadratic because it's not the same slope, it continues to varies. The slope is steeper here versus here. Here it's kind of more zero, and then it kind of steeper, steeper, steeper. So the slope is constantly changing. But we can find the average rate of change. And we said we use the formula for average rate of change. Average rate of change, we said we're going to use the same formula, which is y2 minus y1 over x2 minus x1. So in this case, we want the average rate of change from x equal to 0 to x equals 3. So we need to find, first things first, you need to find the ordered pairs at 0 and at 3. So if x is 0, the y value is here. So this is the point on the graph. So it's 0, negative 2. This is the point 0, negative 2. And if x is 3, and if I go up on the graph, the y value for that, I believe, is 4, which is right here. So if you think about it, 4 and 3, yeah. So basically, the second ordered pair is 3, 4. So these are technically your x1, y1, and your x2, y2. And then you can use the formula to find the average rate of change. y2 minus y1, be careful with that, divided by x2 minus x1. And y2 minus y1 is 4 minus negative 2. Two negatives is a positive, and in the denominator you just get 3. So you're getting 6 divided by 3, and that's actually 2. So the rate of change for this question or this problem is 2. This is how you do it visually, graphically. Number 4 asks you about the rate of change, but you're doing it algebraically. That means you're plugging values into the equation. So for this reason, and it's giving you the equation, and it's giving you 2 x values. So you can treat them as x1 and x2, basically. And all you have to do is plug them in. So all you have to do, you can say, if you plug in for x1 equals to 4, what do we get? We get y equals, or y1 equals, because x1, the corresponding value to x1 is y1. So y1 becomes negative. And remember, we had this good practice of when you plug in, erase the x value, replace it with a parenthesis, and then put the value that you're plugging in inside the parenthesis. It's a good practice. It helps you avoid making mistakes, especially with negatives and exponents. So in this case, you have negative, and then negative 4 squared in parentheses, minus 4 multiplied by negative 4, and then plus 6. So I'm plugging in negative 4. Yeah, this should be negative 4. The first value, we chose it to be negative 4. I apologize. So what does this give us? Negative 4 squared, PEMDAS, is 16 with a negative in front of it. That's negative 16. And then negative 4 multiplied by negative 4 is positive 16, and then plus 6. And this should be equal to 6 because the negative 16 and the 16 cancel out. So technically, my first point is negative 4, 6. And my second point, again, that's for x2, which is 4. I'm going to plug in 4 for x2. So negative, parenthesis, 4 squared minus 4 divided by 4, and then plus 6. So all I did is plug in the value 4 into the same equation. And this gives us 4 squared is 16 with a negative in front of the parentheses, negative 16, and then minus 16 because negative 4 times 4 is negative 16, and then plus 6. And this gives you negative 32 plus 6, which is negative 26. And this is the value of y2. So now you have your x1, y1, and you have your x2, y2. And all you have to do is apply it these are your x1, y1, and your x2, y2. And all you have to do is apply the formula. y2 minus y1 divided by x2 minus, and then x1 itself is -4. So this gives you, this is equal to -32 divided by 8, which is actually -4. And this is your average rate of change, ARC. Okay, so I hope this was helpful. Please let me know if you have any questions, and feel free to stop by office hours or ask me in the classroom. Thank you.